Hey there, and welcome to this video about refactoring. So, what is refactoring? Well, as it says here, it is to restructure software by applying a series of changes, or as we might say, refactorings, without changing its observable behavior. So that means that we can change the software, we can rearrange it, restructure it, remove code, add some new code, but not change the behavior of the software. So that's very important. To this topic, we also can talk about what is clean code actually, and clean code is what we aim for is something that is easy to read, maintain, understand. So, and this might be a little difficult to achieve firsthand. Normally we tend to write code a bit dirty first, and then we refactor it so it becomes more clean. But yeah, easy to read, maintain, because we might extend it, we might work on it, other programmers need to work on the code, and they need to understand it. Clean code also increases the quality of the software, of course, less errors, less bugs, and so on and so forth. And as I said, it is oftentimes normal that you first write dirty code and then you refactor it into clean code afterwards, when you have seen that it works and you maybe see that you can use some design patterns or refactor it in some way. Dirty code. Dirty code sometimes that is the opposite of the clean code, and this happens normally due to inexperience maybe, if you haven't programmed a lot, if you're on tight deadlines, you need to finish off the code quickly and just make it work. You might end up doing some hacks to make it work. Could also be due to mismanagement, that the management doesn't know that it takes time to develop software with a decent quality, and maybe you're taking nasty shortcuts, you're doing it the wrong way, you have bad habits when programming, when developing software, and that could be very, very potentially dangerous if you are using nasty shortcuts to complete the code. And this might end up in what we sometimes call spaghetti code. So refers to a ball of spaghetti with everything just wrapped up, and if we should include coupling, normally there is a very high coupling in this code because it is just one big mess and it takes a long time to figure out how it works. And all these things might lead to something that we can call technical debt. The explanation to it is poorly written code. If you're using this dirty code approach, it will get harder and harder to refactor as time passes by. And this will affect the speed or velocity with which you can develop software. And we have these illustration down here, and let's have a look at what they try to illustrate here. So first off, if we look at the first illustration here, we can see that we have the velocity in one axis and we have the time on the other one. And if we have the red line there, we can see here, keep writing crappy code. We can see if we continue to have dirty code, crappy code, the velocity will go down. And this means that it will take, we will produce less code as the time passes by. And it will be more and more difficult to maintain it and also to refactor it. If we stop writing crappy code, we can keep the velocity at a certain steady pace. So this will mean that we will stop this decrease in velocity, and we can keep the same pace in our development. Alright, so if we look at the other one here, and let's say we have some crap in our code base, we keep the old crap, that is up here on the blue line, and if we will keep the same velocity for here. And if we clean up the old crap, meaning we refactor it, we apply some design patterns, we loosen the coupling, and so on and so forth, we can raise the velocity with which we program. So this might be a good approach, that we actually clean up some old crap, which is the opposite of the other illustration. So why should we refactor in the first place? Well, as I mentioned here, higher overall development speed, or maybe a steady, stable speed. We will have an optimized code base size. We might decrease it because we can remove code, we can make it more smarter, we can reuse code, so on and so forth. As I said, reusability, we can maybe use the same code, same methods, different places in our code, and not have redundant code. We can see it is easier to maintain, and this relates to the coupling also. It will be easier to extend and to understand for other developers that might not know the code base. And this will ultimately promote low coupling and high cohesion as we want it, and also promote the solid principles. And these are all very, very good things, especially when we deal with large software programs. Alright, so thank you very much for watching, and in the next videos we will look a little bit on something that relates to refactoring, which is code smells. Alright, so thanks for watching. Bye bye.